Imagine a natural disaster strikes halfway across the world, a remote military base suddenly runs out of ammunition. An allied nation urgently needs air defense missiles. Normally that cargo travels by aircraft or ship, hours, days, sometimes weeks. What if it could arrive in under an hour? That's exactly what the US military is exploring, using SpaceX's Starship as a global cargo delivery system capable of moving massive payloads anywhere on Earth at hypersonic speeds. It sounds like science fiction. It's already being studied through the US Space Force and Air Force Research Laboratories Rocket Cargo Program. Before we get into it, if you're finding value in these breakdowns, hitting like and subscribing to Reach Defense Media genuinely helps us keep putting this kind of coverage out. We'd really appreciate it. Starship is the largest and most powerful reusable rocket ever developed, roughly 120 meters tall when stacked with its super heavy booster. Unlike traditional expendable rockets, the goal is rapid reuse. Launch, land, refuel, fly again. If that vision fully delivers, the cost of moving extremely heavy cargo could fall dramatically. Flight testing continues improving reusability and heat shield performance, though the system is still maturing. The military's interest comes down to one word: speed. Today's C-17 Globemaster III is an exceptional airlifter, but it still takes many hours to cross the globe. Ships carry enormous loads at sea speeds. Starship could theoretically move roughly a C-17's payload anywhere on Earth in about an hour via suborbital flight, delivering humanitarian aid, missile interceptors, special operations equipment, or critical spare parts to the other side of the planet before a conventional cargo aircraft reaches its first refueling stop. The applications go beyond combat. After earthquakes, tsunamis, or major hurricanes, roads and airports are often destroyed. A reusable heavy-lift rocket landing near a disaster zone could deliver generators, water purification systems, medical teams, and emergency supplies within hours instead of days. Future conflicts may also involve attacks on ports, airfields, and shipping lanes. Rocket-based logistics would create an entirely different delivery route that's considerably harder to disrupt using conventional naval or air interdiction. Payload potential adds to the appeal. Starship was designed to carry over 100 metric tons in some configurations, opening possibilities well beyond small packages. Entire vehicles, mobile hospitals, missile batteries, construction equipment. Depending on mission requirements and available landing infrastructure, rapid deployment options expand significantly. The honest challenges are substantial though, and this is still very much an experimental concept. Infrastructure is arguably the biggest hurdle. Starship can't land at an ordinary airport. It needs specially prepared landing zones, safety clearances, cryogenic propellant infrastructure, and extensive ground support. Building that network globally would require enormous investment, and without it, the concept's flexibility is severely limited compared to conventional airlift. Launch itself creates problems. A rocket ignition generates intense noise, heat, and blast effects that make launches near populated areas extremely difficult. Most missions would likely need offshore or remote facilities, which cuts into the responsiveness advantage that makes the concept attractive in the first place. Cost remains an open question. Starship is designed for reuse, but routine operational costs, maintenance, inspection, refueling, turnaround times need to become predictable before rocket logistics can compete economically with conventional airlift for most missions. Nobody has those numbers yet. There's also a strategic concern that doesn't get discussed enough. A Starship launch looks remarkably similar to a large ballistic missile launch. During a crisis, an unexpected rocket launch could create serious confusion for other nuclear powers. Robust international notification procedures would need to exist before this becomes operational. The last thing anyone needs is a military logistics run being mistaken for something considerably more alarming. And realistically, most military cargo simply doesn't need to arrive within an hour. Aircraft, ships, and ground transport remain far more efficient for routine logistics. Rocket cargo complements existing networks rather than replacing them. Its value is specifically for missions where speed matters more than cost. Will Starship replace cargo aircraft? Almost certainly not. Could it become the world's fastest strategic transport for the most critical missions? That possibility is becoming increasingly real, and the US military is clearly paying close enough attention to find out. Ensure you subscribe to Reach Defense Media for more content like this.